All right, it started.
Did you get through last week okay?
Yeah, once I was able to watch the video she sent out and kind of walk through a problem with using those videos, I was able to get it pretty quick.
I struggled with last week. I thought it was hard.
Yeah, well, I think it was hard at the beginning just because all of the problems had to do with that one process, and until she emailed it out, no instructional information was really given on it. But
yeah. All right. So number one, I got for little r, I got P or 0.645.
okay.
Did you get that?
Yeah, so for Q I had 0.65, and then for P I had 0.35.
Oh yeah, we got the same. I just used 3 decimals, I think.
Okay.
And then what did you get for B?
For B I got, for the homozygous dominant, I had 12.25%.
How did you do that again?
So I just did 0.35 squared.
0.35 squared. Oh yeah, Q to P squared plus 2PQ.
Yep. And then for the heterozygous, I got 45.5. And homozygous recessive, I had 42.25%.
Oh, did you get Nika's text?
Yeah, I sent her a reply.
Okay. Yeah, that's what I got.
Okay. And what about for C then?
For C, I just subtracted the percentages from 1. So, I'm sorry, I don't have my answers on me. I'm just looking at a blank document.
Oh, that's okay. So you subtracted it?
Yeah, from 1. Because hetero is... Would hetero be 1 minus 0.65 and 0.36, or...
I think because in B, the middle step was calculating the percentage of heterozygous.
Yeah.
And so it would just be the total population times that percentage.
Okay.
If that makes sense. That's what I did.
So what did you get for D?
For D, I got red was 42.25, and white I got 57.57. Sorry, 57.75.
Okay. And did you already submit 2 and 3?
Yes.
Did you have any questions on those?
I don't think so. It was basically the same thing as 1, but just different orders.
Yeah. For them, well, I got 100%. Same, but then like I got 100% on it, so now I don't.
Okay. And then 4 was the same thing as well. I think, wasn't it basically the same?
Yeah.
But it was, I had question marks on 5. I didn't know how to do some of those last parts on 5. A was what we've been doing about determining the allele frequency. But then when it asked about the chi-square test, I didn't know what to use. I mean, obviously you need the observed and the estimated, but I didn't know. We have the observed, but I didn't know what to use for the estimated.
I don't know either. Did I email her real quick?
Email who?
The Professor Mayo. Or something.
Well, did she get back that fast?
Yeah.
Okay, sure.
Yeah, and then you could tell Mika she can join us.
Okay. I'll text her.
So for number 5 for A, to get the allele frequency, how did you do that?
How did I do it? I have to remember. Let's see, what did I do? Oh, so what I did, so we talked about this in like general biology, like making a chart. So for the 168 homozygous dominant, you have 2 M's for each of those.
Mm-hmm.
And so for that grouping, you have 336.
Why?
Because you have to multiply it by 2 to separate the M's to get your total number of M's, the allele M.
Oh, okay.
And then for the heterozygous, you'd have 30 of each. Because you have 30 M's and 30 N's. And then for the last one,
total is 366.
Right. Mm-hmm.
Is that the answer?
No, so that's the total number of M's, and then you'd have to divide it by the total alleles, and that would give you the frequency.
The total alleles, so do you divide it by 200 or 400?
400. Because each person has 2 alleles.
So it's 366 divided by 400.
Right.
So 0.1915, 0.92.
Mm-hmm. Yep.
And then for N, that would just be 0.09 or 0.08.
Yeah, I had 8.5%, but yeah, somewhere in there. Because it's the 34 divided by 400.
Oh, I just subtracted it.
Right, yeah. That works.
Uh, okay. Is Mika gonna join?
She said she was going to. So yeah, I just had. Oh, go ahead.
How do you usually do the chi-square?
Well, the chi-square is just that equation that it's the sum of estimated minus observed divided by estimated. And then that's when you get the value when you go to the chart that we did 2 weeks ago.
Where's the chart at? In lesson 3?
I think so, because I know it was on the test. So I think it was that week before the test that we learned it.
I'm not seeing
And it was even on the test page, like it gave the 2 equations, and one of them was the chi-square,
it. Okay, I see.
if that's easier for you to find.
We plug it into that equation and then use the chart.
Right. But I don't know what we're supposed to, because we have an observed phenotype that it gave us.
What would we use for the observed?
I think that's just what you would use the numbers that it gave you for.
The
100.
frequency? Or the given?
I think you would use the given number of 30. But I don't know what you would use for the estimated because we don't make any estimations.
So which part of the equation, where would 30 go? Is it the E or is it the O?
I think it would be the O.
And then what do you put in for, what's that weird E called?
The what?
The weird shaped E?
It's the sum of.
That's the sum of?
So like if you have multiple observations and estimates, you add them all up in this equation.
What if you don't?
Yeah, so it would just be plus itself. So
Hey guys,
hi.
what number are you guys on?
We're
Um,
number 5.
Number 5?
Yeah, did you do that one?
I don't even have myself ready to hear.
We weren't sure how to do the chi-square test with only one value, or which numbers we should use for that one.
Professor Mayo said she posted a video
Oh,
for everyone.
okay.
In an announcement and the note from instructor discussion board.
Oh, I have no clue. I knew how to do A.
So, glancing through the video really fast in the 60 seconds that I looked at it, it looks like they took the allele frequency that we got in A and put it in the other equation for genotype frequency, and then used that as your estimated. If that makes sense. I'm not a very visual person, so it probably wouldn't make sense to me.
Can you repeat that, John, just so I can follow?
So I think we all knew how to do A, and we got the allele frequency.
Mm-hmm.
So you take that and you put it in the genotype frequency equation, the p squared plus 2pq plus q squared.
Oh, okay.
And that will give you a frequency of the genotypes. And so then you can multiply that by the total of individuals, 200, to give you a number of genotype, or a number for each genotype of what we expect to find.
Okay, so basically, the p square, in this case, it would be m, right? The frequency m?
Right.
Oh, okay. Alrighty.
And so then with just those estimated values, and then the other values would be our observed, and then you just plug in.
1,4 when I did the genotype frequency, so where would that go?
Sorry, say that again?
I got 1,4 for heterozygous when I did genotype frequency. So that's our estimated?
So this says you should have, for the heterozygous, you should have gotten estimated of 0.0072 as the frequency, and then times 200 should give you 1.44.
Yeah, that's what I got. I got.
Oh, okay. Yeah, so that would be the estimated.
And then you put that in half, so it would be 30 minus 0.14 squared over 1.
Mm-hmm. So 30 minus 2, or 30 minus 1.14 squared divided by 1.44.
And then that's your answer.
Yeah, so that's the answer in B. And then for C, I think you'd have to look at a chart. And then suggest why.
I don't think it necessarily have to do anything with a chart.
What?
I don't think it necessarily have to do anything with a chart. I'm not really exactly sure when you say a chart, what do you mean by that?
Well, it had the chi-square value chart that we looked at a couple weeks ago
Uh-huh.
to see if it was at equilibrium or not, to see if we're sure of our hypothesis or not. It might have given new values this week. I can't remember in the slideshow or the notes that it said if it's, I want to say like 50, it used the value of 50, but I don't remember if that's right or not. I'd have to look back. But yeah, just according to that value we get on B, we have to make a decision on whether it is at equilibrium or not. So,
I understand that. I have another question.
Nika, did you have any questions on the first four? We've already kind of talked through them, but if you had questions, we could go back and look at them real quick.
Yeah, I actually had a question with number... I think it's number 4, but hold on. Actually, it was letter A. Letter A, the last bullet, the last bulletin board. Bullet.
On number 4A?
Yeah, 4A, the last slow bullet.
The B type blood?
Right.
Okay. I got 18.7%.
How did you come about to that?
So it's the frequency of the IB times the frequency of small I times 2.
No, like what I'm saying is like I know that for the first 4 bullet, like the formula is like for the bullet 1 is p squared, 2 is 2pq. But I'm saying what is the formula for the last one?
So it's also 2 whatever. I don't know if it's PQ. I get confused with when you add a third one, what letters you use. But
that's actually adding a fourth one. Well, a third one, but yeah.
Right. So it's the same as the second bullet point, except you're using the values for the ones that it gives.
Okay.
So basically what I understand as I did it is if it's the same, if it's homozygous, you just square it. If it's heterozygous, then you do the 2 times the value of each of them.
So yeah, okay, I see what you're saying with that, but I'm saying, could you see how number 1, it tells you, I said number 1, how letter B, it tells you 2pq? How would you know to do 2p whatever for the last one?
Because I think it gave you the frequency for each one.
I don't think so.
So like in the instructions for it gives you for A, B, and little I, the frequency. So you're just plugging those values in. And then for the heterozygous, yeah, so like we said, if it's homozygous, you just square it. If it's heterozygous, you go 2 times the value of both of them.
Okay. Oh, alrighty, I get it. Yep, perfect sense. I was kind of confused, but now that you said that, I think I get it.
Okay,
Thanks for that.
no problem. All right. Any other questions?
No, I'm actually fine.
I'm good too.
All right. Do we want to try to set a time for next week? I know we weren't able to get a hold of each other this week for whatever reason.
Yeah.
Is Wednesdays what work best if we try going Wednesday again?
Or Tuesday, perhaps. Well, it doesn't really matter to me. I'm very flexible.
Wednesdays are good for me.
Okay. So if we say, what did we say before, 11 or 10:30? My time, sorry. I always think my time.
We could do 11.
Is that okay for you, Nika?
You said 11?
Yeah, so that would put it at 1 o'clock your time?
Hold on. Oh, that's fine. That's fine.
All right. So Wednesday, 11 o'clock. My time.
I'll see you guys then.
All right. Thanks.
Bye.
Bye.